Hello, today I'll be showcasing to you an end-of-year matrices question. Now, it says that in a small village there are two doctor clinics. One is owned by Dr. Black and the other is owned by Dr. Green. It was noted that 3.5% of Dr. Black's patients moved on to Dr. Green's clinic and 5% of Dr. Green's patients moved on to Dr. Black's clinic. It says, note that all additional losses and gains of patients by the clinic may be ignored. At the start of the particular year, it was noted that Dr. Black had 2,100 patients on the register compared to Dr. Green's 3,500 patients. Now, if you don't understand the question, I suggest that you pause it and read it again. Now, the first part of the question here, it says write down a transition matrix T indicating the annual population movement between clinics. Now, to better understand this, we'll draw a transition diagram. In this transition diagram, we have here Dr. Black's clinic and Dr. Green's clinic. Now, in the question, it says that 3.5% of Dr. Black's patients moved on to Dr. Green's, and 5% of Dr. Green's patients move on to Dr. Black. But how many stay with Dr. Black and how many stay with Dr. Green? Now these are percentages, so we might subtract them by 100. So 100 subtracted by 3.5% is 96.5. 100 subtracted by 5% is 95%. And remember, in the transition matrix, because it's percent per 100, we'll be dividing them by 100. So this is how you'd write your transition matrix. You can also write it with G, and then B, B. But basically what this means is it helps you like not forget. So from Dr. Black's patients to Dr. Black's, you'd write the number here. From Dr. Green's to Dr. Black's, you'd write the number here. And from Dr. Black's to Dr. Green's, you'd write it from here. And from the green to green, you write it here. So basically the amount from Dr. Black to Black is going to be 0.965. From green to black, it's going to be 0.05. And from black to green, it's going to be 0.035. And from green to green, it's going to be 0.95. So like this is how your answer is going to turn out as. Now, the next part of this question, now you can pause and read it if you wish to, but it says find a prediction for the ratio of the numbers of patients Dr. Black will have compared to Dr. Green's after 2 years. Now, already in my eigenvectors and eigenvalues video, I already spoke about n and how it works, so I won't further explain that deep. If you don't understand it, I suggest you go watch that video. But basically it's a number of terms. So this one's easy, and it's only a 2-mark question, so we don't have to do that much working out. But all we have to do is just take our transition matrix, put it to the power of 2, and multiply it by the number of patients we have. So this is Dr. Black's patients and Dr. Green's patients. So here's our answer. These are Dr. Black's and these are Dr. Green's, and the ratio is going to be like this: Dr. Black's patients and Dr. Green's patients. Now, this is another question, and this is a bit longer question because it's 6 marks. You can pause the video and read it yourself. So it says find matrix P. It wants us to find matrix P with the integer that T is equal to PD P inverse, where D is a diagonal matrix. Now, I already spoke about P and D and also my last eigenvalues and eigenvectors video. I said that P is just the eigenvectors and D is the eigenvalues, but it's lambda 1, 0, 0, lambda 2. So yeah, and to find P and D, we of course have to find the eigenvalues and eigenvectors. So we're going to be using our formula, which I also spoke about in the last video. So after we substitute our formula, it's going to come out like this: 0.965 minus lambda, 0.05, 0.35, 0.035, 0.95 minus lambda, and we'll take the absolute value of that and equal to 0. Now we're going to write it down to make it more clearer, and not cross multiply, but multiply them each. But after we've multiplied them each and gotten a quadratic equation, all we have to do is use our poly tools, and that'll give us our eigenvalues, which are lambda 1 and lambda 2. So we've already found D by using these, but the question doesn't ask for D, it asks for P. So we use we use the eigenvalues to solve the eigenvectors, which help us to find P. So we take lambda 1 and substitute it back into here, and after we substitute them, this is the matrices that we'll be getting. We multiply the matrices by x and y equals 0 to get an equation. So we're only going to use the first equation of this, so 0.5x plus 0.5y equals 0. We move the x to the other side, it becomes negative 0.5x. Negative 0.5x divided by 0.5, because we're moving the 0.5 from the y to the x. So it's going to be just y is equal to negative x. So our eigenvalue is going to be we're going to make x equal to 1. So the norm y is going to be -1. So our eigenvector is going to be 1 and -1. We do the same thing for our second eigenvalue. We substitute it in, and it gives us the matrix negative 0.035, 0.05, 0.035, negative 0.05. We multiply by x and y equal to 0. We only take the first equation. If the first equation is not suitable, you can always take the second. The answer should come out the same. But we bring negative 0.035x to the other side, so then it becomes 0.05y equals to positive 0.035x divided by 0.05. That's going to give us y is equal to 0.7x. Now we wanted the absolute value, so we're going to make x equals to 10. 10 times 0.7 is going to equal to 7. So our eigenvector is going to be 10 and 7. So by using this, we can find our p. So this is our answer. You don't have to look further more, but basically p is going to be equal to 1 and -1, 10 and 7. And I said earlier that d is just going to be lambda 1, 0, 0, lambda 2. And p inverse, this is for the question that's going to be coming up. But you find, of course, p inverse using the determinant, 1 over the determinant, and then you move, exchange and change the signs. And this is the formula. So moving on to another question. This is also 6 marks, so this will require a couple pieces of working out. So it says, hence show that the long-term transition matrix t to infinity is given by t to infinity is 10 over 17. So basically he's just asking, prove that t to infinity is equal to this. So that's all it wants right now. So all we do is, I also spoke about the n last time, so watch that video if you haven't watched it. It will help you. But so as we said, t to the power of n is the same as p d to the power of n p inverse. So we just substitute that in, except we haven't added the. So this is just it without the n's. So this is it without the n's, but we're gonna add the n's here up, because we're gonna have as n is equal to infinity, 0.915 is going to be, if it's going to be any decimal to the power of infinity, it's going to be such a really low number, to the point that it's like it's very low. It's not exactly 0, but it's very close to 0. So we just say it is 0. But 1 to the power of infinity is also just going to be equal to 1. So our matrix D is going to be equal to 0, 0, 0, 1. And then we just substitute that in. So we say t to the power of n is equal to 1 over 17 times p times d, and then times d to the power of n, and then times p inverse. And if we substitute all of these in, you'll get the answer of 10 over 17, the same one as it wanted here. Of course, you can write, this is of course the same as saying, what's it called, 1 over 17 times 10, 10, 7, 7. But the question is asking you to prove that it looks like this. So make sure it's the same format. It is the same. These two are the same. But it's preferred to use, these two are the same, but it's preferred to use this one. Now, here is the last question. This is only a 2-mark question. So it says, you can pause the video, but it says, hence or otherwise determine the expected ratio for the long-term amount of patients Dr. Black would have compared to Dr. Green in the long terms. All we have to do is just take our answer t, our transformation to the power of n, because it's to the long term. And then we just multiply it with the number of patients that each of them had started with. So this was Dr. Black's patients, and this was Dr. Green's. And we'll get, here is the amount of Dr. Black had after in the long term, and here is the number of patients that Dr. Green has after the long term. And then we'll just write down the ratios like this, Dr. Black's and Dr. Green's, and that should be your answer. If this video helped you, please, what's it called, just subscribe. And I have a Discord channel, which is the Shadow Wizards Math and Money Mayhem. So yeah, if you'd like to join, I'd appreciate it. If you have any questions, because I know I didn't explain anything in that much detail, please ask and comment if I said anything incorrect. Thank you very much.